A hassle a day may keep the doctor away. I mean, that quote just completely flipped the script for me.
Oh, yeah. It's a wild way to start, right?
Totally. It's from this prominent researcher, Dr. Dabhar. And when I first read it in the dossier we're looking at today, I actually had to read it twice.
Because it goes against literally everything we've been taught.
Exactly. Because, if you're listening to this right now, chances are you feel some level of stress in your life. And you almost certainly view that stress as this purely toxic, like radioactive element that you need to just eradicate at all costs.
Right. We have this really universal assumption that all stress is inherently damaging. But the sheer volume of data we have now, I mean, we're talking decades of biological research, psychological surveys, neurological scans. It paints a much, much more complicated picture of what is actually happening inside our bodies when we feel overwhelmed.
And so that is our mission for today's deep dive.
Right.
We're taking an extensive look into this really comprehensive stack of research on the profound physical effects of stress.
Yeah, we really want to unpack what stress actually is.
Right, and why Americans are practically swimming in it right now. And most importantly, how this invisible force literally, physically reshapes the architecture of your brain.
But we aren't just here to talk about the damage, right? We're going to look at the biology of resilience.
Yes, how you can harness your own physiology to do more than just survive. But to really grasp how it affects us today, I think we need to strip away our modern assumptions.
Yeah, we have to look at the origin of the concept itself, because the way we use the word stress in, everyday conversation is actually quite divorced from its scientific roots.
I was so surprised to see in the historical context that it didn't start as a medical or psychological term at all. Like, the etymology traces back to physics.
Right, it goes all the way back to the 17th century, to Hooke's law in engineering and physics.
Robert Hooke, right?
Robert Hooke. He was studying elasticity, and he defined stress as a measure of the internal forces acting within an elastic system when an external load is applied.
Okay, so we're talking about like the tension on a steel beam when heavy trucks drive over a bridge.
Exactly.
The trucks are the load, and the internal tension inside the seal is the stress.
That's spot on. It's a mechanical measurement of how much pressure a material can withstand before it, deforms or breaks.
Wow.
And then from there, the term migrated into economics in the 18th and 19th centuries. Economists started using it to describe the very real physical and mental symptoms that people exhibited when they were under the burden of extreme indebtedness.
So the pressure of owing money was acting like that external load on the human system.
Exactly.
The human being becomes the steel beam, and the debt is the heavy truck.
That is the perfect way to look at it. And it actually wasn't until the 1930s that the realm of biology truly adopted the term.
Oh, really? That late?
Yeah. There was this pioneering endocrinologist named Hans Selye, and he defined biological stress as the non-specific response of the body to any demand for change. He recognized that whether you are exposed to extreme cold or a physical injury or emotional trauma, the body mounts a surprisingly uniform physiological defense.
Any demand for change. I mean, that is broad. But the psychology definition that evolved later feels much more, applicable to daily life.
Oh, definitely.
Like, the modern psychological definition states that stress is a dynamic process occurring when you appraise that the situational demands placed on you exceed your available resources.
And the key word in that definition is appraise. It is not an objective reality, right? It is an internal calculation. Your brain is constantly doing math.
Right. It's the feeling of having 10 hours of necessary tasks to accomplish, but only 8 hours in the day.
Yeah.
Or staring at $1,000 worth of bills with only $800 in your checking account. The demand objectively exceeds the resource.
And when you look at the raw data spanning decades, Americans are deeply, chronically in the red when it comes to those resources.
The numbers are just staggering. Like, when you look at the longitudinal trends, we have data tracking the perceived stress scale, the PSS.
Over a 26-year period, right, from 1983 to 2009.
Exactly. They surveyed thousands of adults across the country. And the scores didn't just drift upward, they jumped significantly across almost every demographic.
Yeah, the jump is wild.
Overall, perceived stress scores increased by 29% in men and 18% in women over that time frame.
I mean, a nearly 30% jump is a massive societal shift. And when you dig into the demographic breakdown of who is feeling this most acutely, the picture gets very specific.
Right.
First, women consistently report higher overall stress levels than men. And a huge driver of that difference seems to be the burden of family responsibilities.
Yeah, the polling reflects a stark divide there.
Yeah.
Like 56% of women cited family responsibilities as a major ongoing stressor, compared to only 42% of men.
Interestingly, though, women report higher stress. The research suggests they often employ completely different biological coping mechanisms than men.
Oh, right, the tend and befriend thing.
Exactly. While the classic stress response is fight or flight, women often default to a tend and befriend response. They seek out social support and prioritize the protection of offspring, which is actually mediated by hormones like oxytocin.
That makes total sense, using social cohesion as a buffer.
Mm.
But social cohesion isn't the only buffer, is it?
No, not at all. Income and education provide a massive shield against this epidemic.
Yeah, the 2009 survey data show that people with advanced degrees reported approximately 30% lower stress levels than those who hadn't completed high school.
Because socioeconomic status fundamentally alters that internal math we talked about.
Right.
If you have higher income, your available resources are larger, so fewer daily demands are appraised as overwhelming. Like in 2006, the average stress score was 25% lower for people earning more than $75,000 compared to people earning less than $25,000.
Which totally explains why money, work, and the economy are consistently the top three causes of stress reported across all these surveys.
Oh, absolutely.
But there's one demographic trend that I found genuinely confusing when I was reading the dossier. The data shows that stress levels decrease in a graded fashion as we age.
Yeah, that surprises a lot of people.
Like the youngest demographic, people under 25, report the highest stress levels. But for people 65 and older, their stress levels were remarkably low.
And crucially, they saw no significant change over that entire 26-year period where everyone else spiked 30%.
Right. Why is that? Are older generations just becoming numb to the demands of life?
Well, the psychological consensus points away from numbness and toward adaptation. It is essentially the accumulation of mature coping skills.
Okay.
Think about it. When you are 20 years old, a blown tire on your car might feel like a catastrophic event that ruins your entire month.
Right, because your financial resources are low.
Exactly. And your experiential resources, your proof that you can survive adversity, are almost non-existent.
You just haven't built the database yet.
Exactly. But when you are 65, a blown tire is merely an annoyance. You have 4 decades of empirical evidence proving that you can handle a blown tire, navigate the repair, and move on. You appraise the event differently because your internal database tells you that your resources exceed the demand.
It's like a been there, done that protective shield. That is fascinating. But, I mean, regardless of age, the sheer volume of stress the general population is dealing with is causing a crisis in our healthcare system.
A massive crisis, and the system seems entirely ill-equipped to handle it.
Yeah, the sources estimate that between 60 to 80% of all visits to primary care physicians in the U.S. have a stress-related component.
Which is huge. Patients are walking into clinics with tension headaches, severe gastrointestinal issues, chronic fatigue, unexplained muscle pain.
But the kicker is the treatment response. Out of all those visits, only 3% include any form of stress management counseling.
It's really tragic.
The medical system is treating the physical symptoms, prescribing a painkiller for the headache or an antacid for the stomach, but completely missing the root cause in 97% of cases.
And this systemic failure to address the underlying psychological burden is why primary care is now essentially being referred to in the literature as the hidden mental health system.
Wow, the hidden mental health system.
Yeah. Physicians are consistently counseling patients on nutrition, maybe 17% of the time, and physical activity around 12% of the time. But the psychological friction that is actually driving the patient into the clinic just gets ignored.
It is the equivalent of taking your car to the mechanic, because thick black smoke is pouring out of the engine, and the mechanic simply hands you a pine-scented air freshener to hang on the rearview mirror instead of checking the oil.
That's exactly what it is.
You are masking the symptom while the engine is literally destroying itself from friction.
And the economic friction of that hidden damage is staggering. Work-related stress and the associated health problems cost U.S. organizations an estimated $200 billion or more every single year.
$200 billion.
Yes. That accounts for absenteeism, employee turnover, lost productivity, and direct healthcare costs.
$200 billion.
Mm-hmm.
I'm trying to reconcile that massive figure with the quote we started with.
Right, the hassle-a-day quote.
Yeah. If stress is driving 80% of doctor visits and bleeding the economy for hundreds of billions of dollars, how can Dr. Dobhar claim that a hassle a day keeps the doctor away? That seems entirely contradictory.
It does seem contradictory, but only because we have fallen into the trap of lumping all stress into one monolithic, toxic category.
Okay.
Biological reality is far more nuanced. There are actually two distinct faces of stress. The destructive force we have been talking about is known as distress.
Oh.
But there's a second, highly beneficial form known as eustress.
Eustress, spelled E-U-S-T-R-E-S-S, positive stress.
Exactly. Eustress involves a transient, temporary increase in your physiological arousal. It's a short-term spike in hormones like cortisol and adrenaline.
Okay.
And when experienced in manageable, discrete bursts, that biological spike is actively good for you. It creates a state of optimal alertness and pleasurable engagement.
Give me a real-world example of eustress. Like, what does that actually look like for someone going about their week?
It is the biological response to a highly demanding situation that is driven by excitement rather than fear. Starting a new, highly anticipated job, moving to a new city,
Okay.
walking down the aisle at your wedding, having a baby, a first date with someone you were incredibly attracted to.
Oh, right. On a first date, your heart is pounding, your palms might be sweating, your digestion slows down. Your body is technically mounting a stress response.
Exactly.
But you don't want to run out of the restaurant.
Yeah.
You are hyper-focused on the conversation.
Because your physiology is elevated to help you perform in that high-stakes social situation. To visualize how this dictates human performance, psychologists use what is called the inverted U model.
Okay, an inverted U.
Imagine a graph. The horizontal x-axis represents the amount of pressure or stress you are under. The vertical y-axis represents your level of performance.
Okay, so on the far left of the graph, the stress level is near zero. What happens to performance?
Performance is abysmal. With zero pressure, humans experience boredom, apathy, and what is sometimes called rust out.
Rust out. I like that.
There's just no motivation to act. But as the external pressure increases, you start moving up the curve. You enter the area of optimum performance at the very peak of the inverted U.
So right in the middle.
Yes. Your brain is flooded with just enough eustress to make you sharp, focused, energized, and highly efficient.
But I'm guessing the peak doesn't last forever.
No, it doesn't. If the pressure continues to mount past your available resources, you tip over the peak. You start sliding down the right side of the inverted U.
Oh, no.
Yeah, eustress turns into distress. Performance rapidly deteriorates, anxiety takes over, and if the pressure doesn't let up, you hit the bottom right corner. Complete physiological and emotional burnout.
Wow. This completely changes the goal. The objective of stress management shouldn't be zero stress, because zero stress is the flat line of boredom.
Right.
The goal is learning how to surf the peak of that inverted U.
Yeah.
But what I find so compelling in the research is that the external trigger doesn't dictate where you land on the curve.
No, it doesn't.
Two people can face the exact same event, and one experiences peak eustress while the other plunges into burnout.
Because the stimulus itself is neutral, the biological response is entirely dictated by the individual's appraisal.
Okay.
The literature often uses the analogy of a difficult mathematics exam. For a student who naturally excels at math and enjoys problem solving, a complex take-home final is a stimulating challenge.
Right.
It pushes them to the top of the inverted U. They experience eustress. But for a student who has struggled all semester and fears failing the class, that exact same piece of paper triggers intense distress and cognitive paralysis.
The paper is identical, but the internal chemistry is completely different. And the dossier highlights a fascinating study involving 114 medical students that illustrates this perfectly.
Oh, that's a great study.
Medical school is universally understood to be a high-pressure environment. But the researchers found a striking gender divergence in how the students biologically process that pressure.
Yeah, they tracked the students' day-to-day stress levels and cross-referenced it with their attendance and clinical performance.
And what did they find?
They observed that the female medical students actually exhibited higher attendance and better day-to-day performance when exposed to routine stress compared to the male students.
So the daily friction of the hospital was actually acting as fuel for them.
Exactly. The authors of the study concluded that the situational stress had a motivating, beneficial effect on the female cohort. They were synthesizing the pressure as a challenge to be met, keeping them at the peak of the inverted U.
Wow.
whereas the male cohort showed signs of performance deterioration under the same daily load. And the deciding factor in how anyone processes that load comes down to their coping strategy.
Right. The research categorizes coping into three main buckets: action-oriented, emotion-oriented, and acceptance-oriented.
Correct.
Action-oriented is pretty straightforward. You change the environment, like your apartment is too noisy, so you move.
Right.
Acceptance-oriented is when you were facing something utterly outside your control, like a terminal illness diagnosis, and the goal shifts simply to emotional survival.
Yes.
But emotion-oriented coping is the one that seems to dictate the difference between eustress and distress on a daily basis.
Because emotion-oriented coping comes into play when you cannot immediately change your physical environment, but you have the power to alter your cognitive interpretation of it.
Oh, I see.
And your ability to successfully use this strategy is deeply intertwined with your baseline personality traits. There was a highly revealing study looking at 40 healthcare professionals, nurses, social workers, psychiatric therapists, and those working in elderly care.
Some of the most emotionally demanding jobs in the healthcare sector.
Extremely demanding. Out of these 40 professionals, all working in similar high-stress environments, exactly 20 of them developed severe clinical burnout, and 20 of them did not.
Wait, really? A perfect split?
A perfect split. The external demands were a constant, so the researchers looked at their psychological profiles.
What separated the two groups?
The 20 individuals who burned out consistently exhibited high levels of neuroticism and trait anxiety. They possessed lower emotional stability.
Okay.
Crucially, they tended to perceive their work environment as inherently threatening, and they often held unrealistic expectations of themselves and their patients. When a stressful event occurred, their internal appraisal system immediately catastrophized it.
And the 20 who thrived, the ones who didn't burn out, despite facing the exact same patients and the exact same systemic pressures.
They possessed high emotional stability. They were trusting, easygoing, and forgiving. They approached their colleagues and patients with the expectation of fair treatment and good intentions.
So they didn't view a setback as a threat to their survival.
Exactly. They viewed it as a temporary puzzle to solve.
There was another study involving 296 nurses that reinforced this, specifically highlighting the trait of extroversion.
Yeah, extroversion acts as a powerful biological shield. The nurses who scored high in extroversion were naturally more cheerful, energetic, and eager to engage in proactive activities to overcome daily hurdles.
Right.
Because they were outgoing, they naturally fostered robust social support networks within the hospital. They literally built their own safety nets through optimism.
I want to pause on this because the implications are just wild. We are saying that you can essentially optimism your way out of cellular damage.
That's a great way to phrase it.
Like choosing to interpret a difficult boss as a temporary challenge rather than a mortal threat actually alters the sequence of neurochemicals your brain pumps into your bloodstream.
It intercepts the biological cascade before it can cause structural damage. Your psychological appraisal is the gatekeeper to your endocrine system.
That puts so much agency back in our hands when dealing with a demanding job or a chaotic household. But the problem is, it's easy to deploy coping strategies against a stressor you can plainly see.
Right. Visible threats are easier.
Yeah, a screaming boss is obvious. A stack of past due bills is obvious. But the sources dive deep into a category of stressors that are completely invisible, acting on our nervous system without us even realizing it.
Environmental and technological stressors are particularly insidious because human biology has not had the evolutionary time to adapt to them.
Let's look at the physical environment first.
Well, noise pollution is a chronic stressor that bypasses our conscious appraisal entirely. Studies have shown that children living in a noisy airport community where the decibel level is constantly elevated by low-flying jets tend to have significantly higher resting blood pressure than children living in quieter neighborhoods.
So their autonomic nervous system is essentially stuck in a state of low-grade hypervigilance because loud noises evolutionarily signal danger.
Precisely. Their bodies are waiting for a predator that never arrives. And then you have ultraviolet radiation from the sun.
Oh, wow. I wouldn't have thought of that.
We rarely think of as a massive physiological insult, particularly for Caucasian populations, who account for over 90% of melanoma cases.
The mechanism there is fascinating. UVA rays penetrate deep into the skin, causing premature aging and tanning, which is actually a sign of DNA damage.
Right.
But UVB rays are the primary cause of sunburns and play a key role in the development of skin cancer and actinic keratosis, those rough, scaly patches on sun-damaged skin.
And yet, despite the clear biological threat, only about 3 out of 10 adults in the U.S. routinely practice adequate sun protection. We voluntarily expose ourselves to an invisible stressor.
That's
And
crazy.
we haven't even touched on air pollution. The smog in major metropolitan areas directly increases the risk of respiratory and cardiovascular diseases.
Though the data did offer a fantastic countermeasure for that, right? Urban forestry.
Yes.
The presence of tall trees in a neighborhood acts as a massive biological filter, significantly reducing the particulate matter and mitigating that environmental stress.
Trees acting as an air purifier for the neighborhood. It's amazing.
But as concerning as a noisy airport or city smog might be, there is a modern, invisible stressor that almost every single person listening to this is carrying in their pocket right now.
Yes.
And the physical and psychological toll it is taking is terrifying. We have to talk about the digital toll, specifically problematic internet use, or PIU.
Internet addiction has really moved from a cultural punchline to a heavily researched clinical reality. It is generally defined by an inability to control one's use of the internet, leading to severe negative consequences in daily life.
And the metrics they use are pretty eye-opening.
Yeah, the clinical metrics researchers use to define problematic use often look for non-essential internet activity exceeding 5 hours a day or more than 30 hours a week.
5 hours a day of non-essential scrolling.
Yeah.
I know for a fact that metric just made a lot of people mentally check the screen time app on their phones and swallow hard.
I'm sure it did, and the parallels to substance addiction are undeniable.
Really, like actual addiction.
Oh, yes. The diagnostic criteria include losing track of time, experiencing intense irritability or withdrawal symptoms when offline, actively concealing the extent of the usage from family, sacrificing basic needs like sleep or food to stay online, and repeated failed attempts to cut back.
The demographics in the research are staggering. Current U.S. data indicates that 93% of adolescents and young adults use the internet regularly, and within that demographic, the prevalence of full-blown internet addiction can reach as high as 26.3%.
More than 1 in 4 young people.
It's unbelievable.
And the behavioral manifestations are highly gendered as well. Adolescent girls typically weaponize the internet for social networking and meeting new people, which can lead to intense interpersonal stress, whereas adolescent boys lean heavily toward generalized surfing and violent online gaming.
But the biological and social consequences are uniform across the board.
Yes. Excessive daytime sleepiness, plummeting academic performance, a stark decrease in face-to-face family communication, profound loneliness, and significantly elevated psychological stress markers.
And when we narrow the focus from the internet generally to cell phones specifically, the numbers get even more extreme. A comprehensive survey of college students found them spending an average of 7 to 10 hours daily on their cell phones.
The breakdown showed females averaging close to 10 hours a day, largely driven by messaging apps, spending roughly 105 minutes a day just sending texts,
Wow.
while males averaged around 7.7 hours. In one massive survey, an astonishing 60% of college students openly admitted they felt they might be addicted to their devices.
But the cruelest part of this digital addiction is the underlying motivation. Like, why are we staring at these glowing rectangles for 10 hours a day?
The paradox of the smartphone is that we use it as a coping mechanism. More than 40% of the respondents in these surveys explicitly stated that they turn to their cell phones to help them relax, to artificially improve their mood, or to escape from real-world problems.
So it's like, I am feeling overwhelmed by my classes or my job, so I am going to doom scroll social media to numb out the stress.
Exactly. It is an emotion-oriented coping strategy that fundamentally misfires, because the clinical data proves that excessive cell phone use is inherently associated with heightened anxiety, severe sleep disturbances, and an overall increase in physiological stress.
Oh, wow.
The very tool you're relying on to escape your anxiety is actively compounding it.
It is a closed, self-sustaining doom loop. And to fuel the energy required to stay in that loop, we reach for another, thoroughly modern stressor, the energy drink.
Yeah, energy drinks are aggressively marketed as mood enhancers and performance boosters, but structurally, some of these beverages contain up to 3 times the caffeine found in an average can of soda, alongside unregulated herbal stimulants.
Which is just a massive jolt to the system.
It is. The research is very clear here. While the acute, immediate effect might feel like a positive burst of energy, regular consumption defined as more than one energy drink per week is significantly correlated with heightened anxiety, disrupted sleep architecture, and higher baseline stress levels.
And students are chugging these in the library when they feel stressed about upcoming exams, assuming it will help them perform.
But the studies show that regular consumption is actually associated with lower overall academic performance.
It is another broken coping mechanism that tricks the body.
Oh.
But I want to circle back to the internet addiction data for a moment. You mentioned that the behavioral symptoms mimic substance addiction,
Yes.
but the sources reveal that the similarities go far deeper than just behavior. It literally alters the physical structure of the brain.
This is perhaps the most sobering neuroimaging data in the entire dossier. Researchers conducted whole-brain voxel-wise analysis on adolescents suffering from clinical internet addiction and compared them to healthy controls.
Let me stop you right there. Voxel-wise analysis. I'm picturing like a Minecraft block in my head. What exactly is a voxel, and what are we looking at in these brain scans?
It's a great question. In 3D neuroimaging, like an MRI, a voxel is essentially a three-dimensional pixel. It represents a tiny, specific volume of brain tissue. By analyzing the brain voxel by voxel, researchers can detect microscopic structural differences between two groups.
Oh, okay.
And what they found in the internet-addicted adolescents were significant abnormalities in the brain's white matter.
White matter is the wiring, right? The communication cables connecting different parts of the brain.
Yes, it is the myelinated axons that transmit signals. These white matter abnormalities were heavily concentrated in the regions of the brain responsible for emotional generation, self-control, and executive decision-making.
Wait, so staring at a screen for 10 hours a day physically damages the wiring that allows you to control your own impulses.
It degrades the structural integrity of the control center. Other studies looking at gray matter, the actual neuron cell bodies, showed decreased density in these same areas.
It's terrifying.
And when researchers utilized positron emission tomography, or PT scans, to observe the metabolic activity of the brain in real time, they discovered that individuals addicted to internet gaming displayed neurological abnormalities that shared striking, undeniable similarities with the brain scans of people addicted to severe narcotics.
That is incredibly heavy. So let's take stock of the barrage we are under. You have a demanding boss, a noisy street, city smog, a glowing smartphone commanding your attention 10 hours a day, and an energy drink flooding your system with 300 milligrams of caffeine.
That's a lot.
When all of this pressure hits you, what exactly is happening under the hood of the human body? Like, how does the biological machinery actually process this stress?
To understand the machinery of stress, we first have to understand the machinery of peace. The human body's baseline equilibrium is a state called homeostasis.
Okay, homeostasis.
It is the miraculous, automatic tendency of your organism to maintain critical variables like blood pressure, core temperature, heart rate, oxygen levels, and blood pH within extremely narrow, safe ranges.
Yeah.
Stress, at its core biological level, is a disruption of homeostasis.
And the system responsible for managing that disruption is the autonomic nervous system, the sort of automatic, involuntary operating system that runs in the background.
Correct. The autonomic nervous system is divided into two competing branches. You have the sympathetic nervous system, which you can conceptualize as the body's gas pedal.
Gas pedal, got it.
Its job is to rapidly mobilize energy and prepare the organism to react to a threat. Opposing it is the parasympathetic nervous system, the brake pedal. Its job is to calm the body down, conserve energy, and restore homeostasis once the threat has passed.
Okay, let's walk through the exact biological cascade. Let's say a stressor appears. You look at your phone, and an incredibly angry, threatening email from your boss pops up on the screen.
Okay, good scenario.
From the moment the light from the phone hits your retinas, what is the sequence of events?
It begins deep in the limbic system, the mid-level evolutionary older part of your brain. The sensory information, the visual processing of the words in the email is instantly routed to the amygdala.
The amygdala.
Yes. The amygdala is your brain's threat detection center. It is where fear and emotional memory are primarily registered.
So the amygdala is like the security guard sitting in the basement, staring at the camera feeds, looking for trouble.
Exactly. If the amygdala's pattern recognition software interprets that email as a perceived danger, it doesn't wait for your conscious, logical brain to verify it. It instantly fires a distress signal to the hypothalamus, which acts as the ultimate command center for the nervous and endocrine systems.
The security guard sees a man with a gun on the camera, hits the red button, And calls the commander.
And the commander, the hypothalamus, ruthlessly executes the famous fight or flight response, a term originally coined by the brilliant physiologist Walter Cannon.
Right.
This survival protocol is executed in two distinct overlapping phases. The first is the fast response, driven by the sympathetic adrenomedullary system.
How fast is the fast response?
It is functionally instantaneous.
Yeah.
Within 2 to 3 seconds of reading that email, neurons in the sympathetic nervous system, specifically a nucleus in the brainstem called the locus coeruleus, secrete a neurotransmitter called norepinephrine.
2 to 3 seconds.
Wow. This acts as the initial spark. Then, between 20 and 30 seconds later, the signal reaches the adrenal medulla.
Your adrenal glands sit right on top of your kidneys, right?
Yes. The medulla is the inner portion of the gland. Upon receiving the signal, it dumps massive, overwhelming amounts of epinephrine and norepinephrine directly into your bloodstream. Epinephrine is the hormone most people know as adrenaline.
So within half a minute of checking your inbox, your entire circulatory system is flooded with adrenaline.
Yep.
How does that physically alter the machinery of your body to prepare for fight or flight?
It radically reconfigures your physiology for immediate physical survival. Epinephrine binds to beta-adrenergic receptors in the heart muscle, causing your heart rate to dramatically spike.
Okay.
Norepinephrine binds to receptors in your blood vessels, causing them to severely constrict.
Pushing the blood pressure through the roof so blood pumps harder and faster to the muscles?
Exactly. Simultaneously, the smooth muscles in your lungs relax, dilating your airways so you can draw in maximum oxygen. Your gastrointestinal tract activity is forcefully inhibited. Digestion slows to a complete halt because wasting energy digesting your lunch is a terrible strategy if you are about to be eaten by a predator.
Yeah, that makes sense.
Blood flow is diverted away from the skin and digestive organs and shunted directly to your major skeletal muscles.
And the body needs fuel for those muscles instantly.
Which is why the pancreas is drafted into the response. The adrenaline inhibits the secretion of insulin and stimulates the release of glucagon. This tells your liver and skeletal muscles to rapidly break down stored glycogen into free glucose, flooding your bloodstream with instant combustible energy.
And this isn't just happening from the neck down. Your brain function alters as well.
Yes, the electrical activity of your brain shifts. Beta brainwaves, which are associated with intense focus and alertness, significantly increase.
Right.
Meanwhile, alpha waves, which indicate a relaxed resting state, decrease. You are locked into a state of hyper-alert, tunnel vision fear response.
Is the biological equivalent of pulling the fire alarm in a massive commercial skyscraper. The sprinklers instantly go off, the heavy fire doors slam shut and lock, the elevators drop to the ground floor, the sirens blare.
Exactly.
The entire building is instantly, violently reconfigured to deal with a catastrophic emergency.
Mm-hmm.
And that is incredibly brilliant engineering if there is actually a fire. If a literal tiger is chasing you through the jungle.
Right.
But if you pull that internal fire alarm every single time you check your inbox or every time you get a push notification on your phone,
Okay.
the building is going to get ruined by the water damage from the sprinklers.
That is a flawless analogy. The fast response is a blunt instrument designed to save your life in a crisis. It was never intended to be activated 20 times a day by minor interpersonal friction. But the adrenaline surge is only the first half of the cascade. Adrenaline burns out quickly. If the threat doesn't disappear in a few minutes, the body initiates the slow response to sustain the fight or flight state. This is managed by the HPA axis.
The HPA axis, hypothalamic pituitary adrenal axis. Walk me through the mechanics of the slow response.
Remember the hypothalamus, the commander that initiated the first alarm? As the adrenaline is hitting your bloodstream, the hypothalamus is simultaneously secreting a hormone called CRH, corticotropin-releasing hormone, along with arginine vasopressin.
Okay.
These travel a microscopic distance down to the pituitary gland, which hangs just beneath the brain.
The pituitary receives the CRH, and what does it do?
It manufactures and secretes ACTH, adrenocorticotropic hormone, into the general bloodstream. The ACTH acts as a chemical messenger, traveling all the way down to the adrenal glands again.
Back to the kidneys.
But this time, it targets the adrenal cortex, the outer layer of the gland. It commands the cortex to synthesize and release cortisol.
Cortisol, the most infamous stress hormone in the human body.
Yes, cortisol is a steroid hormone synthesized from cholesterol. Because it requires a complex chain of command to produce, its timeline is slower. While adrenaline hits in seconds, peak cortisol levels in the blood are usually observed about 25 minutes after the HPA axis is activated.
I see.
And here is the crucial mechanical difference between the two. Adrenaline is water-soluble and largely cannot cross the blood-brain barrier. It primarily ravages the body.
What cortisol?
Cortisol is lipid-soluble. It effortlessly crosses the blood-brain barrier. It literally floods the brain tissue, seeking out two specific types of receptors waiting for it. Its job is to keep blood sugar elevated and blood pressure high long after the adrenaline wears off, ensuring you have the stamina to keep running or fighting for hours if necessary.
So we have this invisible secondary flood of hormones marinating our internal organs and our brain tissue. Because this internal alarm system dictates so much of our health, scientists needed a way to measure it reliably.
Right, which isn't easy.
Yeah, how do researchers actually quantify the invisible weight of stress?
Yeah.
Because just handing someone a questionnaire and asking, on a scale of 1 to 10, how stressed are you,
Yeah.
has to be incredibly flawed.
It is notoriously unreliable. Self-reported questionnaires are subject to intense subjective bias. People might lie because they want to project an image of stoicism and toughness to the researchers.
Or they might not even know.
Exactly. They might have lived with high stress for so long that they have lost their baseline. They genuinely don't realize how stressed they are. Furthermore, individuals often mask their dysfunctional coping mechanisms.
Oh, sure?
A person drinking heavily every night to suppress their HPA axis might not disclose that on a survey. To get objective truth, science relies on biomarkers.
Which brings us to a laboratory experiment detailed in the dossier that is, frankly, one of the most diabolical psychological setups I have ever read about. The Trier Social Stress Test, or the TSST.
Developed by researchers at the University of Trier in Germany, the TSST is globally recognized as the absolute gold standard for reliably inducing acute physiological stress in human subjects within a controlled laboratory setting.
Let me set the scene for the listener, because it sounds like a nightmare.
Yeah.
You volunteer for a scientific study, you arrive at the lab, and the researchers put you in a room for a 10-minute anticipation period.
The worst part.
You sit there alone, knowing that a difficult task is coming, letting your imagination run wild. Then, you are brought into a brightly lit room and told you must immediately deliver an impromptu, persuasive speech for a job interview.
Right.
But you weren't talking to a supportive HR rep. You were speaking to a panel of supposed behavioral experts who were sitting behind a table staring at you with completely deadpan, expressionless faces.
They're brutal.
They do not nod, they do not smile, they just stare.
Right.
And you are informed that a video camera is recording your every microexpression for later evaluation.
The protocol is engineered with devastating precision to trigger two of the most potent psychological triggers for human beings: interpersonal anxiety and the fear of negative social evaluation.
And if sweating through a 10-minute speech in front of stone-faced judges wasn't enough, the moment you finish, they force you to do mental arithmetic out loud.
Oh yeah, the serial subtraction.
They will say, start at the number 1022 and subtract 13, over and over, as fast as you can. If you hesitate or make a single math error, the deadpan judges interrupt and force you to start completely over from 1022. Just reading the methodology made my heart rate spike.
And it works flawlessly every single time. Researchers take samples of the subject's blood or saliva before the anticipation period, and then again at specific intervals after the 20-minute ordeal. The biochemical response is explosive.
What do they see?
They record massive spikes in ACTH, prolactin, growth hormone, and most importantly, cortisol. Salivary cortisol levels typically increase 2 to 4-fold from baseline just from enduring that fake job interview.
A 400% spike in cortisol just from feeling judged by strangers.
They also measure a biomarker called salivary alpha amylase. While cortisol tracks the slow hormonal HPA axis response, alpha amylase is an enzyme in saliva that acts as a fantastic non-invasive surrogate marker for the lightning-fast sympathetic nervous system activity.
Ah, okay.
It shows how hard the adrenaline hit them.
So the TSST proves beyond a shadow of a doubt that psychological friction creates a violent biological reality. But here's the crux of the entire deep dive. What happens when the stress isn't a 20-minute math test in a laboratory?
Right.
The TSST ends and the subjects go home. What happens when the stress is a toxic marriage or crushing inescapable financial debt or a demanding boss that you have to wake up and face every single day for 5 years?
This is where we arrive at the cortisol paradox and the devastating mechanism of chronic stress.
Yeah.
Under normal acute stress, like running from a dog or enduring a TSST, your cortisol levels spike. But the human body is deeply intelligent. It possesses a built-in kill switch.
A kill switch.
Yes. That high concentration of cortisol circulating in the blood provides negative feedback to the HPA axis.
How does the kill switch work mechanically?
As cortisol floods the brain, It binds to what are called high-affinity mineralocorticoid receptors in the hippocampus and hypothalamus. Think of these receptors as highly sensitive locks, and cortisol is the key.
Okay, locks and keys.
When the cortisol key turns the lock, it sends a clear chemical message to the commander. We have enough cortisol in the blood. The threat has been handled. Stand down.
Fire is out, turn off the sprinklers.
Precisely. The hypothalamus stops releasing CRH, the HPA axis deactivates, the parasympathetic nervous system engages the brakes, and the body gracefully returns to homeostasis.
Often.
But under severe, chronic, unyielding stress, the rules of biology change. The negative feedback loop breaks.
Wait, why does it break? If there is so much cortisol in the blood, shouldn't the kill switch be activated constantly?
Because the continuous toxic flood of cortisol overwhelms the system, the high-affinity receptors become desensitized or downregulated.
Yeah.
Instead, the massive volume of cortisol begins binding primarily to a second set of locks, low-affinity glucocorticoid receptors. And when cortisol binds to these low-affinity receptors in high volumes, the stand-down order is muffled. The hypothalamus never receives the clear signal to shut off the alarm.
The internal thermostat is completely shattered. The heater is blasting, but the sensor doesn't know the room is boiling.
The body realizes it cannot return to its original healthy homeostasis. So it attempts a desperate, dangerous compromise. It tries to create a new normal state of hyper-aroused physiological balance.
What's that called?
This state of adaptive yet biologically damaging survival is known in the literature as the allostatic load.
The allostatic load, it sounds like a heavy burden.
It is the cumulative biological wear and tear of chronic stress. It is the price the body pays for being forced to adapt to a hostile environment long term. And you can see the evidence of this load clearly when you measure a person's cortisol awakening response, or ECR.
Explain the cortisol awakening response. How does that curve normally look?
In a healthy, unstressed individual, cortisol secretion follows a strict circadian rhythm. It drops to its lowest point around midnight, allowing for deep, restorative sleep. But right before you wake up, it starts to climb.
Okay.
When you open your eyes, within the first 30 to 45 minutes, your cortisol levels naturally spike by 50 to 75%. It is the necessary biological burst of energy required to jumpstart your metabolism and face the day. From that morning peak, it slowly, steadily declines until bedtime.
Okay, so that is the healthy curve. What does the curve look like for someone carrying a massive allostatic load, someone whose thermostat is broken?
The disruption generally manifests in one of two distinct pathological ways. In many patients suffering from severe depression or acute ongoing trauma, the HPA axis becomes violently hyperactive. They exhibit a massive, exaggerated cortisol awakening response.
Really high cortisol.
Yeah. One study highlighted in the dossier showed that unmedicated depressed patients were secreting 25% more cortisol in their first hour awake than healthy controls. Their bodies are literally flooding them with excess stress hormones just to force them out of bed.
And the second way it breaks.
Exhaustion. The HPA axis becomes deeply dysregulated and fatigued. This is the physiological hallmark of severe burnout. The curve becomes flat.
A flat curve.
Yes, they do not get that crucial morning spike. Their morning cortisol is abnormally low, making it nearly impossible to summon energy, and conversely, their bedtime cortisol stays abnormally high, preventing them from sleeping.
Wow.
A fascinating study of 338 police officers found that the highly stressed officers had significantly lower cortisol awakening responses than their low-stress peers. The chronic trauma of police work had essentially worn out their adrenal response.
Their internal battery is just dead. And historically, mapping that curve required making subjects spit into a plastic tube multiple times a day for weeks to test their saliva.
Which is tedious.
Yeah. But the sources highlight a newer biomarker that is absolutely mind-blowing.
Yeah.
Hair cortisol.
Oh, yes. Hair cortisol analysis is a revolutionary advancement in stress research. While saliva or blood testing only gives you a snapshot of cortisol levels at that exact minute, hair provides a longitudinal record.
Because it grows slowly.
Right. Cortisol circulating in the blood is continuously incorporated into the hair shaft as it grows out of the follicle.
It is exactly like reading the rings of a tree.
Yeah.
You can take a single strand of hair, measure it out centimeter by centimeter, and literally look back through time.
Because human hair grows about a centimeter a month.
You can look at the chemical composition and say, oh, looking at this 3-centimeter mark, 3 months ago you experienced a massive allostatic load. You can map a person's trauma history.
And the data perfectly aligns with the theory. The studies show elevated hair cortisol concentrations in endurance athletes, night shift workers, unemployed individuals facing financial ruin, and people actively grieving the death of a spouse. Interestingly, the hair analysis also proves the exhaustion phase. In patients suffering from severe long-term PTSD, the hair cortisol might show a massive spike during the initial trauma. But as you look closer to the scalp representing the present day, the cortisol levels actually drop abnormally low, again indicating that their HPA axis has essentially given up.
So we have to ask the critical question, what does this all mean for the listener? If your HPA axis is out of whack from a toxic job, if your body is flooded with cortisol that is binding to those low-affinity receptors day after day, what is this toxic chemical soup actually doing to the physical structure of your brain?
This is the pivot point where the science gets truly alarming. This is where we transition from discussing reversible chemical imbalances to irreversible structural erosion.
Okay.
When cortisol levels are elevated for a prolonged period and continuously bind to those low-affinity glucocorticoid receptors, the cortisol ceases to be a signaling hormone. It becomes a neurotoxin. It is literally toxic to your nerve cells.
Is poisoning the brain. Let's get specific about the damage. Where does it hit first?
The primary casualty is the hippocampus. This is a seahorse-shaped region deep in the brain that is absolutely critical for learning, memory consolidation, and emotional regulation.
The memory center.
Right. Under normal conditions, the hippocampus possesses neural stem cells. Throughout your life, through a miraculous process called neurogenesis, these stem cells divide and mature into brand new functional neurons.
Like a factory constantly producing fresh troops to reinforce the front line of your memory.
Exactly. But under the heavy influence of chronic cortisol, neurogenesis is violently suppressed. The high cortisol environment literally hijacks the stem cells. Instead of developing into necessary neurons, the stem cells are forced to convert into oligodendrocytes.
Wait, what are those?
These are glial cells whose only job is to produce myelin, the fatty substance that insulates nerve fibers.
I'm going to make sure I understand the mechanism here. Factory gets the wrong blueprint. Instead of building the actual electrical wiring, the new neurons, you need to think clearly. It just endlessly manufactures the plastic insulation for wires that don't exist.
That is precisely what is happening, and the physical result is devastating. Without new neurons to replace the dying ones, the hippocampus physically shrinks.
Brain volume loss.
Yes, you experience measurable brain volume loss. This structural damage directly translates to mild cognitive impairment, severe memory deficits, and an inability to regulate mood. But the damage isn't contained to the hippocampus.
It attacks the prefrontal cortex as well, right? The area right behind your forehead responsible for high-level executive function, decision-making, and emotional control.
Yes. Chronic stress, major life traumas, and clinical depression have been shown to physically shrink the medial prefrontal cortex. Brain imaging studies utilizing that whole brain voxel-based morphometry we discussed earlier have consistently demonstrated significantly reduced gray matter volume in the prefrontal cortex and the right insula in individuals subjected to chronic stress.
The dossier mentioned a specific genetic mechanism responsible for this shrinkage in the prefrontal cortex, something called GATA1. How does that work?
Imagine your brain's genome is a massive piano, and the keys are individual genes. The GATA1 transcription repressor is like a heavy weight placed on certain keys, preventing them from making a sound.
Good.
In the brains of depressed patients, the GATA1 gene becomes highly activated. Its job is to repress the expression of other crucial genes that are responsible for forming and maintaining the synaptic connections between neurons in the prefrontal cortex.
It silences the genes that build the bridges between brain cells.
Exactly. When researchers artificially stimulated the GATA1 gene in animal models, the subjects quickly exhibited behavioral symptoms of severe depression, and autopsies revealed actual physical loss of brain volume and synaptic density in that specific area.
It is a physical erosion of the self.
Yeah.
Culturally, we still casually use the phrase, "it's all in your head," to dismiss mental health struggles, implying that anxiety or depression are just imaginary weaknesses.
Right, which is just so wrong.
But this data proves that depression and chronic stress are profoundly, terrifyingly physical. They are actively chiseling away at the gray matter of the brain. And there is a real-world study in the dossier that captures this physical toll in a way that gave me chills. The 9/11 study.
It is a landmark multimodal neuroimaging study, and it perfectly illustrates the structural echo of trauma. Researchers gathered a cohort of 36 healthy adults, A portion of these individuals were physically present within 1.5 miles of the World Trade Center during the terrorist attacks on September 11, 2001.
Okay.
The control group consisted of adults who were living more than 200 miles away on that day, but who subsequently moved to the New York area.
So they put all 36 of these adults into an MRI machine more than 3 years after the towers fell.
Yeah.
What did they find when they compared the brains of the people who were close to ground zero versus those who were far away?
The adults who had closer physical proximity to the trauma during the attack exhibited significantly lower volumes of gray matter in their hippocampus, their medial prefrontal cortex, their insula, and their amygdala compared to the control group.
3 years later.
Even more than 3 years later, the sheer biological terror of that day was still physically etched into the architecture of their brains.
The physical distance from the trauma literally dictated the volume of their brain tissue years later. That is haunting.
It really is.
But while 9/11 was a massive historical trauma, the sources make it clear that everyday, ongoing chronic stress is uniquely predictive of this kind of damage, particularly when it comes to triggering depression.
Yes.
The statistics show that about 20 to 25% of people who experience major stressful life events eventually develop clinical depression. But what fascinated me is that not all stress is created equal in the brain's eyes.
This is a crucial nuance in the literature. Researchers draw a hard line between non-interpersonal stress and interpersonal stress.
That's difference.
There is a rigorous study that tracked 119 previously depressed individuals over an 18-month period. The goal was to see what specific life events triggered a relapse into a major depressive episode.
And the results were completely counterintuitive to how we think about stress.
They found absolutely no significant statistical correlation between non-interpersonal chronic stress, such as severe financial debt, going bankrupt, or losing a job, and the recurrence of major depression.
Going bankrupt didn't trigger the relapse.
It caused distress, certainly, but it didn't push them into clinical depression. However, chronic interpersonal stress, ongoing toxic conflicts in a romantic relationship, severe friction with a close friend, or inescapable family drama, those factors uniquely and powerfully predicted a relapse into major depression.
But why? From a logical standpoint, losing your house to the bank seems like a much bigger threat to your survival than having a screaming match with your spouse. Why does fighting with your partner shrink your brain and cause depression more reliably than losing your life savings?
To understand that, we have to view human biology through the lens of evolution. Human beings are apex predators. But not because we have sharp claws, thick armor, or incredible speed. We conquered the planet entirely because of our ability to form cohesive social tribes. In the ancestral environment, if you lost your physical possessions, the tribe would keep you alive. But if you were excluded from the tribe, or if there was deep, violent instability within your core social unit, you would wander into the wilderness and die alone.
So our brains evolved to view social connection as literally equivalent to oxygen.
Exactly. Your amygdala interprets a failing marriage or a betrayal by a friend as a far more immediate, lethal threat to your existence than a failing bank account. The interpersonal stress triggers a much more violent, sustained cortisol response because your biology thinks you're about to be exiled into the wilderness to be eaten.
That makes perfect evolutionary sense.
Yeah.
And it also explains why early childhood trauma is so uniquely devastating to human development. When the people who are biologically mandated to protect you, your parents, your family, your peers become the primary stressors, the developing brain takes an unimaginable hit.
The sources list childhood maltreatment, physical abuse, emotional neglect, severe bullying as one of the most destructive forces a human brain can endure. The damage is not just psychological. It alters the developmental trajectory of the brain.
How so?
Adults with a history of childhood maltreatment show a severe, measurable reduction in hippocampal volume. Their HPA axis is permanently dysregulated, which dramatically increases their lifetime risk of developing PTSD, major depression, antisocial behavioral disorders, and severe substance abuse.
And just to add one more layer of physiological damage to the pile, there's another mechanism we have to cover before we move on. Oxidative stress. We briefly touched on how cortisol increases this, but what is actually happening at the cellular level?
Oxidative stress is essentially cellular rusting. In the normal process of cellular metabolism, your body produces molecules called free radicals. These are highly unstable molecules missing an electron.
Okay.
To stabilize themselves, they violently attack healthy cells, stealing their electrons and damaging their DNA and cell membranes in the process.
They are molecular thieves. And normally, our bodies produce antioxidants, like vitamin C or glutathione, which act as cellular police. The antioxidants voluntarily donate an electron to the free radical neutralizing it before it can damage the cell.
Exactly. It is a delicate balance. But chronic psychological stress violently throws off that equilibrium. The constant flood of cortisol drastically increases the production of free radicals while simultaneously suppressing the body's antioxidant defenses.
Wow.
The thieves multiply, the police are fired, and the brain tissue begins to literally rust and degrade.
The dossier cited a couple of studies to prove this in humans. One looked at divorced men, another form of intense interpersonal stress.
Yes, the study found that divorced men exhibited significantly lower antioxidant defenses in their central nervous system and were far more susceptible to free radical-induced brain injury compared to married men. Another deeply tragic study looked at postmenopausal women who were acting as the primary caregivers for spouses suffering from dementia.
Watching a loved one slowly disappear while bearing the physical burden of their care is perhaps the ultimate chronic interpersonal stressor.
And the blood work reflected that reality. They found markedly higher markers of oxidative stress and elevated baseline blood cortisol in the caregivers compared to a control group of women with healthy spouses. The psychological burden of caregiving was literally causing accelerated chemical rusting of their brain cells.
Okay, if we stop this deep dive right here, it would unequivocally be the most depressing hour of audio ever recorded. We have painted a stark, terrifying picture.
Very bleak.
We've mapped out the erosion of the mind. We've seen how the modern world weaponizes our own nervous system against us, how cortisol acts as a neurotoxin, how stem cells malfunction, and how our brains physically shrink and rust away. But thankfully, the source material doesn't end in the darkness, because nature rarely builds a mechanism without a countermechanism. There's a biological antidote to this structural erosion, a way to fight back that is just as physically real and scientifically measurable as the cortisol.
And it completely revolves around the physiological protective power of positive emotion and intentional resilience.
I have to admit, when I first read the heading positive emotion as a cure for structural brain damage, my cynical alarm bells went off. It sounds like a bumper sticker.
It sounds very self-help, right?
It sounds like just think happy thoughts, smile in the mirror, and your clinical depression will magically vanish. But the science here is rigorously backed by data, and it all stems from a framework developed by Dr. Barbara L. Fredrickson, known as the broaden and build theory. Walk me through what she discovered.
Dr. Fredrickson revolutionized how psychology views joy. Historically, positive emotions like joy, gratitude, contentment, and love were viewed simply as the absence of stress. They were considered fleeting, subjective feelings with no real evolutionary purpose other than to signal that a person was safe.
Right.
But her theory proposes that positive emotions are highly evolved, active biological adaptations, just like fear.
Just like the fight or flight response is an adaptation to keep us alive.
Exactly. Think about the mechanics of the fight or flight response. Its primary function is to narrow your attention. When the tiger jumps out, you don't notice the beautiful sunset, you don't feel the hunger in your stomach, your aperture closes, you only see the threat.
That makes sense.
But positive emotions do the exact opposite. They arise in safe, non-threatening environments, and their evolutionary purpose is to broaden your momentary thought-action repertoire.
They widen the aperture, they open your mind up to take in the periphery.
Yes. When you feel joy or intense curiosity, your brain encourages play, exploration, and social bonding. And in doing so, it allows you to build long-lasting physical, intellectual, and social resources. The joy is fleeting, but the resources you build while in that state accrue over time, depositing into your biological bank account.
So chronic stress aggressively withdraws resources from the bank. But moments of joy make physiological deposits. What do those biological deposits actually look like under a microscope?
The physical health benefits of accruing these positive resources are highly measurable. Longitudinal studies show that individuals who frequently experience upbeat emotions have stronger immune profiles. They literally catch fewer colds.
Wow.
They have significantly lower markers of systemic inflammation. Their baseline blood pressure is lower. And crucially, their HPA axis is less reactive. Their bodies produce lower cortisol output in response to standard stressors.
They are biologically insulated, and the dossier mentions that it dramatically impacts sleep architecture as well. There was a study of 736 older adults that measured eudaimonic well-being.
Eudaimonic well-being is a specific type of positive emotion. It isn't just hedonistic pleasure like eating a good meal. It is the deep sense of purposeful engagement with life, personal growth, and self-realization.
Okay.
The study directly correlated high eudaimonic well-being with significantly better sleep quality, reduced sleep latency, and fewer nighttime awakenings. Conversely, subjects dealing with high financial strain and social isolation exhibited broken, non-restorative sleep patterns.
And, as we know, deep sleep is the exact mechanism the brain uses to clear out toxins, repair oxidative damage, and consolidate memory. So the positive emotion secures the sleep, and the sleep repairs the brain.
Yes, exactly.
But the real magic of the broaden and build theory lies in resilience. Happy people don't just feel better day to day, they literally bounce back from trauma faster.
They possess what psychologists call a flexible adaptation to the ever-changing demands of life. There was a fantastic study highlighted in the text focusing on postdoctoral research fellows. This is a demographic under immense chronic academic and career stress. They're constantly competing for funding, working brutal hours, and facing heavy criticism.
The perfect recipe for a flattened cortisol curve and severe burnout.
But the study found a clear divergence. The postdoctoral fellows who reported experiencing frequent, subtle positive emotions throughout their day exhibited much higher psychological resilience.
Okay.
This resilience acted as an impenetrable shield, protecting them from developing depressive symptoms despite the intense, high-stress environment of the laboratory.
They had more tools in their toolbox to deal with the pressure.
Because the positive emotions kept their cognitive aperture wide. When you are stressed, your thinking becomes rigid and black and white. Broadened cognition allows for creative problem solving and a wider range of coping skills.
That reminds me of the 9/11 study on college students.
Yes. Following the September 11 terrorist attacks, researchers studied a cohort of college students. They found that the students who, amidst the national grief, were still capable of experiencing subtle positive emotions like gratitude for their safety or deep interest in connecting with their families were heavily protected against falling into clinical depression. The positive emotions improve their adaptive coping strategies.
Okay, this is all incredible news for people who are naturally cheerful, extroverted, and optimistic. But what if you aren't? What if your genetic baseline leans toward neuroticism? What if your natural response to a flat tire is to catastrophize? Are you just doomed to have a shrinking hippocampus? Can you manually manufacture these biological resources?
You absolutely can. Neuroplasticity works in both directions. You can intentionally induce positive emotions to build that resilience muscle.
Really? How?
One of the most compelling studies in the dossier followed 139 working adults. Half of them were assigned to practice a technique called loving-kindness meditation, while the other half served as a waitlist control group.
Loving-kindness meditation. That involves sitting quietly and intentionally directing feelings of compassion and well wishes toward yourself, then toward your friends, and eventually toward people you don't even like.
Yes, it is an active cognitive exercise, and the results were profound. Over the weeks of the study, the meditation group began to self-generate daily positive emotions that actually increased in magnitude as time went on.
It literally is like working out a muscle in the gym. The first week, you lift a 10-pound weight, and by week 6, you were lifting 40 pounds. The brain got better at generating joy.
It did. And true to the broaden and build theory, this manufactured joy created concrete resources. The subjects reported increased daily mindfulness, a deeper sense of purpose in life, thicker social support networks, and crucially, a significant decrease in physical illness symptoms compared to the control group.
Amazing.
They psychologically and physically fortified themselves against the stress of their working lives just by intentionally practicing compassion.
So we have the biological proof. We can build a shield of resilience through gratitude, meditation, and intentional connection. But we have to address the massive glowing elephant in the room.
Money.
Money. If we look back at all the demographic surveys we discussed in the first 10 minutes of this deep dive,
Yeah.
what was the absolute #1 reported cause of stress across almost every demographic? Money. The economy. Financial strain.
It's unavoidable.
It is very easy for a researcher to say, just practice loving-kindness meditation to protect your hippocampus, but people are terrified about paying their rent or buying groceries. So we have to look at the data surrounding wealth. Can money buy happiness? Can securing an abundance of resources permanently eliminate the stress response?
The data surrounding money and biological happiness is incredibly nuanced and often highly counterintuitive. Let's look at the macro level first. The data strongly indicates that gross domestic product, or GDP, does not correlate linearly with the happiness of a nation's citizens.
Really?
Yeah, the World Happiness Report regularly ranks countries like Canada, Switzerland, and the Scandinavian nations at the very top of the list, while the United States often ranks significantly lower, despite possessing a massively larger GDP.
And the longitudinal data for the U.S. is damning. Over the last 50 years, American economic growth and productivity absolutely skyrocketed. We generated unimaginable wealth as a nation. But the self-reported happiness levels of the American public remain completely flat and in recent years have begun to decline.
While concurrently, European happiness levels generally increased alongside their economic growth. And the researchers pinpoint exactly why this divergence exists. It comes down to how we trade our time for that money. Americans work significantly more hours per week and take drastically fewer vacation days than their European counterparts.
And every hour you spend at the office is an hour you cannot spend building your tribe.
Exactly. Time spent generating wealth actively reduces the time available to connect with family, friends, and romantic partners. And as we established earlier, interpersonal connection is the primary evolutionary signal to the amygdala that you are safe.
Wow.
Psychological research consistently shows that human beings report the highest levels of biological happiness during social connection and intimate intimacy, and the absolute lowest levels of happiness while commuting to work or engaging in high-pressure labor.
The irony is just staggering. We voluntarily subject ourselves to 60-hour work weeks, flooding our brains with toxic cortisol in a desperate attempt to make enough money to finally relax and be happy. But the very act of working those excessive hours steals the vital social time that is the only thing capable of producing true biological happiness. We are grinding our own brains into dust to buy peace of mind.
Now, to be clear, the research does not romanticize poverty. Poverty is an acute, devastating stressor. Low income actively exacerbates the emotional pain associated with life's inevitable misfortunes, like divorce or illness.
Of course.
But a massive famous survey of over 450,000 U.S. residents discovered a very specific, fascinating ceiling to the power of money, the $75,000 threshold.
Let's break down exactly what that $75,000 number means in the context of stress.
The researchers found that emotional well-being, which is the day-to-day frequency of feeling joy, fascination, and affection, minus the daily feelings of sadness and anger, rises steadily with income, up to an annual household income of approximately $75,000.
Meaning that climbing out of poverty up to that middle-class baseline massively reduces your allostatic load. It pays for the shelter, the food, the reliable car. It eliminates the biological terror of basic survival.
Yes, it solves the foundational problems. But here is the critical finding. Beyond $75,000, the data showed absolutely no further significant improvement in daily emotional well-being.
None at all.
None. Earning $150,000 or $300,000 might increase your general life satisfaction when you sit back and evaluate your status on a survey, but it does not make your Tuesday morning any happier. It does not generate more daily dopamine or lower your baseline cortisol any further than the $75,000 mark.
That flies in the face of everything capitalism teaches us.
Yeah.
But the dossier goes even further. It suggests that acquiring significant wealth might actually damage your biological ability to experience joy.
This is a fascinating psychological concept known as the experience stretching hypothesis. The mundane, inexpensive joys of life, feeling a warm, sunny day, drinking a cold beer after mowing the lawn, enjoying a really good piece of chocolate. These small things have a disproportionately massive impact on our daily happiness quotient.
Right.
But studies show that wealthier individuals report a significantly reduced ability to savor these minor positive emotions.
Why? Does the money numb them?
The abundance of wealth stretches their baseline for pleasure. When dining at a 5-star Michelin-rated restaurant becomes your normal Tuesday night, the simple piece of chocolate no longer clears the threshold required to trigger a dopamine release in your brain.
Ah, I see.
The luxury literally raises the bar for what your biology registers as joy, making it harder and harder to feel eudaimonic well-being.
You become a victim of your own elevated tastes. So if working an 80-hour week to get rich won't lower your cortisol, and buying a luxury car will just stretch your dopamine baseline, how should we interact with money to actually reduce our stress?
The ultimate happiness hack hidden in the economic data is beautifully simple, and it loops perfectly back to our evolutionary biology. People who intentionally spend money on others, whether through charitable giving or simply buying a gift or coffee for a friend, report significantly higher levels of happiness than people who spend that exact same amount of money solely on themselves.
Because it all comes back to the tribe. It all comes back to social connection. Spending resources on others strengthens the social fabric. And a strong social fabric is the ultimate signal to the deep brain that we are secure.
It is the biological kill switch. The connection tells the amygdala you are safe. The amygdala tells the hypothalamus to stand down. The HPA axis turns off. The cortisol flood recedes.
Wow.
The stem cells in the hippocampus go back to building healthy neurons instead of useless insulation. The oxidative resting halts. It is all beautifully, seamlessly interconnected.
It really is an elegant machine. We just have to know how to drive it. So let's bring this entire deep dive full circle. We started this hour by trying to simply define what stress is, moving from 17th century physics to modern neurobiology.
Yeah.
We saw the terrifying data on the American epidemic and how the medical system is wildly missing the mark by handing out air fresheners to treat smoking engines.
We examined how the modern environment, from the invisible UV rays and noisy airports to the glowing rectangles we stare at for 10 hours a day, has inadvertently weaponized our own autonomic nervous systems against us.
We walked through the microscopic mechanics of the fight-or-flight response. We learned how chronic stress shatters our internal thermostat, creating a massive allostatic load that floods our brains with neurotoxic cortisol.
Right.
We saw the undeniable MRI scans proving that this toxic soup literally shrinks the gray matter in our hippocampus and prefrontal cortex, while simultaneously rusting our cells through oxidative stress.
But we also uncovered the profound biological power of the antidote. We learned about the inverted U and how eustress can push us to peak performance.
Yes.
We discovered that your personality and internal appraisal dictate your chemical cascade. And most importantly, we explored Dr. Fredrickson's broaden and build theory, proving that positive emotions and intentional social connection physically build the physiological resources necessary to shield the brain from damage.
You might not be able to control the external demands placed upon you. You can't control the noisy street, the demanding boss, or the macroeconomic environment. But the data unequivocally proves that you have immense biologically grounded agency over your internal appraisal and your coping mechanisms.
You have the power to intercept the chemical cascade before it begins.
Which leaves us with a final lingering question, something to really chew on long after you finish listening to this deep dive. The MRI scans from the 9/11 study and the depression research proved to us that chronic negative stress physically erodes the brain. It carves away gray matter over time.
It does.
But we also just learned about neuroplasticity and how generating positive emotions actively builds long-lasting physiological resources.
Which points to a fascinating possibility.
Could intentionally practicing joy, gratitude, and deep social connection do more than just halt the damage? If chronic cortisol has the power to suppress neurogenesis and shrink the hippocampus, could a dedicated daily practice of eudaimonic well-being flooding the brain with oxytocin and dopamine actually reverse the process?
That's a great question.
Could joy literally stimulate those stem cells to aggressively multiply, physically regrowing and expanding those lost neural pathways? If stress is a chemical fire that burns down the architecture of the mind, could connection and gratitude be the blueprint and the lumber that rebuilds it larger and stronger than before?
The underlying mechanics of neuroplasticity strongly suggest that the resources we build through positive emotion are just as capable of structurally remodeling the brain as the damage caused by stress. The brain is always adapting to the dominant signal it receives.
And maybe that is the ultimate takeaway here. You get to choose the signal. A hassle a day might genuinely keep the doctor away, but only if you are actively cultivating the emotional architecture to metabolize that hassle into strength. Thank you for joining us on this massive deep dive. Keep questioning the demands placed upon you, keep connecting with your tribe, and most importantly, keep learning.